Imagine standing on the Great Plains in the dead of winter. The temperature drops far below freezing, and the wind drives a blinding sheet of snow across miles of completely flat terrain. Out here, without modern shelter, hypothermia sets in within minutes. Yet, indigenous families of the Great Plains slept soundly through these exact blizzards. This structure is often called a tent, but its geometry and materials are calculated to manage the specific physics of heat and air. To see how, we have to look past the hide exterior and break down the blueprint for its airflow mechanics and internal climate control. Surviving out here was the result of building a completely self-contained microclimate designed to defeat the cold. Building a heavy, permanent fortress was never an option. Survival depended on following migrating bison herds across the open prairie, meaning the home had to move as often as the food did. This forced a strict engineering requirement. The entire family dwelling had to be dismantled and packed for transport in under 10 minutes. The massive wooden poles supporting the structure were immediately repurposed into a travois, a specialized sled hitched to a horse to carry the rest of the camp's supplies. Nomadic architecture like this requires a total balance. The frame must be light enough for a horse to pull, but stable enough to stand against a gale. It begins with geometry. When high winds hit a square cabin, they slam into flat walls, creating massive structural drag. The teepee's asymmetrical cone shape allows air to flow around its curved sides. This deflection prevents the structure from catching the wind and collapsing. Those steep walls serve a second purpose, ensuring heavy snow slides off the roof before it builds up enough weight to crush the frame. Stretched over this frame is the primary building material of the plains, the American bison. Buffalo hide is a naxal insulator. Its dense fur fibers create a buffer of trapped air that blocks the wind more effectively than woven fabrics. This exterior shell effectively neutralizes the two most immediate threats of the plains, the physical force of the wind and the heat-stripping drafts. A sealed shell creates a problem. A fire inside a closed tent creates smoke that can suffocate you, but opening a hole to vent that smoke lets the cold in. The interior of the teepee uses a specialized ventilation system to solve this. At the very top are two adjustable smoke flaps. By angling these flaps away from the wind, the air moving past the apex creates a low-pressure vacuum that pulls smoke up and out of the living space. Inside, a secondary wall called a tiozon, or liner, is staked to the ground and tied to the poles. This dead air gap works like double-paned glass. Cold air drawn under the outer cover travels up the gap to oxygenate the fire. Above, a drop ceiling called an ozon catches rising heat, forcing warm air to circulate back to the ground. Every layer of the structure contributes to a constant, circular flow of air and warmth. With the drafts managed and the smoke venting, the living space can focus on keeping heat in. Rocks placed in the fire absorb energy during the day and radiate ambient heat long after the flames have gone out. To prevent the frozen earth from pulling heat out of the body, the floor is insulated with reed mats and thick furs. Finally, the entire family sleeps in a ring around the fire, pooling their collective body heat to keep the air temperature stable. This combination of insulation, airflow, and communal heat turned a frozen wasteland into a warm sanctuary. Even in a howling winter storm reaching 30 degrees below zero, the interior of the teepee remains completely calm and firelit. Real technology is the practical application of nature's laws to human survival. Indigenous peoples of the Great Plains solved the problem of the northern winter by building a home that turned the wind against itself.